Mark Dockrell is Scientific Director at the South West Thames Institute for Renal Research. Here he offers a unique insight into the methods, approaches and achievements of a world-class research facility.
So I came to the South West Thames Institute for Renal Research just over 8 years ago. And I came from a very traditional academic background. I have to say, it was quite a surprise to arrive here because I wasn't used to walking past patients on my way to the lab. It's a very interesting experience, and it does create a very real link between the research you're doing and the needs of those patients for that research to be done. In the time I've been at the Institute, we've been involved in a variety of areas of research into different aspects of kidney disease, both the disease, the treatment and the care. For example, recently I had the pleasure of working with a very talented dietitian, and Caroline was interested in the way we assess the nutritional status of renal patients. That's to say, are they tending towards malnutrition? And malnutrition is actually quite a big issue in inpatients in hospitals. And there are many reasons why the way we assess malnutrition in other patients may not apply to renal patients. So Caroline's research was trying to investigate this, to look at different tools for assessing nutrition and then apply them to empirical standards. And what she showed was exactly what we thought, and that is the way we assess nutrition in other patients doesn't apply to renal patients. And we must develop better tools that are specific for our patient group. Now, of course, nutritional research is not really what the Institute does in any big way. I learned a lot from that research, and I learned a lot about patients' needs and patients' care. Fundamentally, I'm a cell biologist. And one of the main areas of research that we're involved in is the cell biology of fibrosis. Fibrosis is that scarring process which will eventually lead to the loss of kidney function. In many ways, it doesn't really matter what initiates the renal disease. It could be diabetes, and it could be hypertension. It could be some form of infection. But the process which actually causes you to lose the function of your kidneys is a production of scar protein. So we are very interested in how the cells in the kidney produce this scar, how they behave in this fibrotic process, and what regulates that. We use human kidney cells, and we try and identify signaling molecules which might be stimulated by diabetes, but cause the cell perhaps to die or to produce excessive scar protein. Now, it all sounds a little bit esoteric to say I'm studying the signaling molecules involved in renal fibrosis, but it's not, and perhaps I can use the example of cancer to demonstrate why it isn't. Cancer is a field where there's been a lot of investment in research over several decades. Drugs that are now being used and developed to treat cancer patients target signaling molecules inside the cells. These are drugs that patients are getting and are very effective. Our belief is the same thing can happen in renal fibrosis. If we can identify specific signaling molecules that regulate cellular processes that cause fibrosis, then down the line, in 10 years' time, someone can have a drug which targets that signaling molecule very precisely, prevents that aspect of fibrosis, and hopefully will mean that although someone may have diabetes, they may get chronic kidney disease, they will never lose renal function. And I guess someone might say, well, that's great, but is that the research that the Institute does? Is it based on helping somebody in 10 or 20 years? Well, yes, partly it is, but also there's another main stream to our research, and that is something which we believe can be helping patients in the very near future. Kidney disease is notoriously difficult to diagnose. You can lose half of your kidney function before the doctor can diagnose it. And that's because the tests we have are limited in their sensitivity. The second main area of research of the Institute here is to improve our diagnosis of kidney disease. So one of the ways we do that is we look for new biomarkers of disease. We look for chemicals that might appear in the urine of renal patients which indicate that their kidneys are failing. We do this in a number of different ways. But using diabetes as an example, a couple of years ago, my colleague Dr. Fanish and I studied 400 patients with diabetes across the Croydon and St.Helier area. And they had different stages of renal disease. And we looked at a whole range of markers in their urine that might indicate they had renal function. And when they compared it to their actual renal function, we were able to identify that 4 or 5 maybe very good indicators of declining renal function. So we genuinely believe that we can develop a panel of markers that will be able to help early diagnosis of renal patients, in this case diabetic, but we have research into other renal diseases, and therefore start the intervention earlier and be able to get the treatment, existing treatments, but be able to focus it so that we can help those patients avoid going on to dialysis. I guess these two areas sound a bit divergent. One, I'm working with the clinician looking at the urine of patients with diabetes, and on the other hand, I'm looking at cells in the lab with scientists and signaling molecules. But they're not divergent. They interrelate. Dr. Fanish is a very competent clinician and a great researcher, and about 6 or 7 years ago, he came to the Institute to do a PhD, and he was studying the cell biology of renal disease. And when he was here, he was very interested in a specific growth factor that occurs in the body called CTGF, connective tissue growth factor, something that we know is involved in fibrotic diseases in other organs. And Dr. Fanish identified that the cells that line the kidney tubule can produce this CTGF under certain pathological stimuli. Now, this is very useful in helping us understand the process of fibrosis. But also, if the cells that line the kidney tubule produce that, we might be able to use it as a marker of kidney disease if it appears in the urine. So when we looked at our panel of potential markers of kidney disease, CTGF was one of them. One of the reasons why we're looking at a range of markers like CTGF and others is because we don't just want a quantitative marker of decline of kidney function. It would be very nice to be able to say patient A has lost 20% of his kidney function, but we're aiming a little bit higher than that. We want to be able to say patient A has lost 20% of his renal function and the damage is specifically in the tubule, or the damage is specifically in the glomerulus, because this can change the drugs that that patient's given, and it can change the way that his consultant gives him advice. I guess it looks like we're doing a lot of things in a very small institute. I've said that we're a small team. And one might wonder, can such a small institute really make any difference to such a big disease? I think that's a fair question, but that depends on the mentality of the people working in the institute. If you've got 5 good scientists who are working in a little shed in a field somewhere, you know, they'd have to be very inspirational to develop something that's going to be meaningful. But that's not what happens at this institute. This institute is set adjacent to one of the biggest dialysis units in the south of England. We have clinicians, doctors, nurses, dietitians who come in the doors of this institute every day who have questions about how they can improve the care or the treatment of their patients. Just like Caroline, a dietitian who said, I'm not sure if this is right. I want to do research. So we work within a dynamic environment of people asking questions because they want to improve the burden that is on those kidney patients. In addition to that, we work at an interesting hospital full of talented individuals. I'm sure every hospital has talented individuals. Giving people the opportunity to use that talent is something different. There's a chemical pathologist who works in this trust called Dr. Marta Lapsley. Marta is an expert in developing tools to help diagnose various diseases, kidney disease. And without Marta, many things that we've done would not have developed. But without us, there's much that Marta wanted to do that she wouldn't have been able to do. She's a very busy clinician, and that clinical load limits the amount of time she can spend in research. But we provide her a facility to interact with, to do better research. 5 miles up the road, there's St. George's, University of London. We've been collaborating with people at St. George's for over a decade now. There are clinicians there who are interested in renal transplant and renal failure, something that no longer goes on here. We no longer have a transplant unit, but we can work on transplant research by collaborating with people at St. George's. There are scientists there who are interested in lung disease, but they don't have the specialist knowledge and some of the tools we have here. So we collaborate with them to expand the impact of the work. The Institute is funded by the South West Thames Kidney Fund, and that core funding of this institute allows it to reach out and collaborate with other groups. If you travel a little bit further into London, you come across King's College London, one of the nation's great research institutes and universities. Well, just because they're King's College London doesn't mean they can do everything on their own. And we collaborate with people at King's on various research projects to try and improve the research they do, the research we do, and the treatment and care of renal patients. Outside the UK, we also have collaborators in the Netherlands and in America. We're always reaching out, looking to share our expertise and learn from other people. There's something hugely gratifying when you're sitting in a lecture hall in some foreign country at an international meeting, and a researcher from Japan is giving a talk and cites work that was done here at the South West Thames Institute for Renal Research, funded by the South West Thames Kidney Fund, and says, it was work by this group which helped me develop my theories about kidney disease. So our impact is obviously greater than it might appear. And when people say to me, but why would you choose to work in such a small institute? I mean, why don't you work at King's or University of Edinburgh, for example? Well, these are great places, and I've worked in both of those places, and they're full of extremely intelligent people doing very good work. But it is, I think, true that sometimes in science, a scientific theory can be a bit like a juggernaut going along a road. If that juggernaut finds it's going in the wrong direction, it is rather difficult to stop, turn around, and go back. You've invested time and effort, and it's a hard thing to do. So I think what happens in science quite a lot is people, rather than changing their theory, they begin to perhaps change the question they've been asked. Sometimes you might think they ignore some of the other evidence. I don't know if that's true, but certainly if you're in a small institute like this, and you find a theory isn't applicable to the question, you have the directors of our board of directors, which is made up of renal patients, their relatives, retired GPs. These people don't want us producing grand theories that explain aspects of science. They want us doing research which is focused on patients. Consequently, if our little car is going the wrong way down the road, we stop, we turn around, and we change direction. We're unique here. We're unique because we have the constant input of those renal patients. We're unique because we have some independent funding. We're very lucky that helps us explore pilot ideas that perhaps don't fit with other people's agenda. And we're unique because we sit inside a busy renal unit and we see every day renal patients. We know what we're here for. I think unique is good. I think when you are unique, you offer something unique. And that has to be a good thing.
You can find out more about the Institute at www.stwtirr.org.uk and support our ongoing research at www.kidneyfund.org.uk.